Okay, students, today we are going to start with our chapter 3 that we are going to discuss about the continuous random variable. All right, so for this chapter, generally it is actually quite similar with some chapter that we learned before. Right, so maybe I'll put it as A2 syllabus and AS syllabus. So I just want to recall it back again. In AS syllabus and A2 syllabus, generally what we have learned is in AS is discrete random variable. Discrete random variable. All right, so for A2, we are going to learn the new one, which is the continuous random variable. Okay, so for AS level, right, when we learn all the discrete random variable, generally we talk everything about summation, because when you want to find out the probability or whatever, right, you have to add the probability together, and then you need to draw a table and so on. And then for continuous random variable in two syllabus, generally we have to use the integration to find out the probability that we want. Okay, so if you compare, this is the difference that we have. All right, but in general, the idea or concept that we have is still almost the same, just that the operation to find out the probability is different. So for AS level, for discrete random variable, mainly we use all the summation, and then for A2 continuous variable, we are going to use the integration to find out the probability, and also the mean and variance, of course. All right, so this is a difference between these two. Okay, so after we cover the continuous random variable, maybe only I make a simple summary for you. What's the difference between the AS and A2? All right. Okay, so let's start with our very brief introduction first about the continuous random variable. Okay, so for this video, the learning outcome is you need to understand the concept of a continuous random variable, and then you have to recall and use the properties of a probability density function. So the properties of probability density function, the idea is more or less the same also as the discrete random variable. All right, but here we apply it for continuous. So let's have a look. Okay, so continuous random variable is defined by its probability density function. In some of the book or maybe some reference book, you will see that they summarize it as PDF, probability density function. And also it can be illustrated by the graph y equals to fx. All right, so for any continuous random variable with this function, okay, between A and B, there are a few things that you need to know. The first one is the probability cannot be negative. So that means of the graph must be always above the x-axis. It cannot be below the x-axis because the probability should be positive one, cannot be negative. That's the first thing. And the second thing is the total probability should be equals to 1. That means the total area under the graph is equals to 1. So I think this is very important. You need to know. So the total area, or maybe the area, is actually equals to the probability. So when you say total probability equals to 1, that means the whole area, shaded area here between the A and B, is equals to 1. Okay, so first important information that you need to know is when you try to integrate, because it's area under the graph, right? So when you try to integrate from A until B, the limit, okay, and then covered by the function, if you do the integration, you'll get the area. So you know that this area is equals to 1. So this is the first important information that you need to know. All right, so this is what we have. And then for this one, they write as all x. All x means that if, let's say, they don't have any graph for you, you need to know that the all x here means that the smallest value defined in the question until the largest value x defined in the question. So usually all the value here, the A and B, will be given in the question itself. Okay, so if I look at this figure, then the formula that I write is this one. But if let's say they didn't give you this figure, then in general, when you want to write the formula, you will see that most of the book they write as negative infinity and then positive infinity for fx, and you will get the equals to 1. So please take note that if let's say you see this negative infinity and then positive infinity, right? Sometimes you need to put in the value, a certain value, but in general they define it like this. Okay, if let's say you have a question and then they tell that your function is from value 1 until 4, let's say. So here you have to put in the smallest value 1, and here you have to put in the largest value at the 4. Okay, so it depends on the question. But no matter how, this is a very important information that you need to know. Okay, and then usually this formula is very useful. Okay, we use it to find the constant in a continuous random variable question. Okay, so later I will let you know what does it mean. All right, but usually we use it to find some certain constants that we don't know yet in the question. All right, so first important thing that you need to know. Okay, and then the second one, when they want you to find out a certain probability. So as an example, if they want you to find this probability, which is between x1 until x2, so which means that you want to find the area under the graph for this x1 until x2, right? Okay, so how to find the area for this? Therefore, you need to do the integration from x1 until x2 for the function fx. So this is the probability for x1 until x2. Okay, so please take note that for continuous random variable, no matter you put the equal sign or no equal sign, generally you will see that all of the answers are the same. Like this one, if you put both equal sign, or this one have no equal sign, this one got equal sign, or the other way around, or also both don't have any equal sign, as long as it is between x1 and the x2, the answer is always the same, which is the integration from x1 and the x2 for fx. So this is to find the probability. Then the just now one is they tell you that when you integrate the whole thing under the graph, it is always equals to 1. Okay? Alright, so this is the two important information that we need, or maybe you need to understand. Alright? Okay, so basic property. These are the two basic property that you need to know for continuous random variable. Okay, so let us start and see how can we actually answer this kind of question. Alright, so when you want to solve the random continuous random variable question, right? Usually you will see a function given, okay, with domain given at the end. Okay, so this is the probability density function. So we call this as probability density function. And usually I will tell students, if can, you try to read the question properly and see what are they talking about. So for this question, they are talking about the annual salary. X is the annual salary measured in thousands of dollars paid to salesperson. So they are talking about the annual salary. Alright. Okay, so this is a function that we have. And then first, they want to find the value of C. So if you look at the C, C is a constant term in our is a constant in the function, right? So usually when they want to find this kind of constant in the function, generally you need to use the very first property that we learned just now, which is when you try to integrate the function, okay, for the whole limit that you have, and you let it equals to 1. Okay, so now our concern now is how to put in the limit here. So to put in a limit, you have to look at the domain of the function. So they say x must be greater equals to 16. That means the smallest value should start 16 until the value which is infinity. Okay, because here they didn't give us the upper limit. So we'll treat as upper limit as infinity, like positive infinity. Okay, so this is what we have here. And then you let it equals to 1 because you know that when you integrate this whole thing, the total area should be equals to 1. Okay, so again, remember this is the first property that we learned just now. Okay, so try to integrate this one. C is a constant. I will just copy it. How to integrate x power negative 7 over 2? So to integrate x power negative 7 over 2, you take power plus 1, which is become negative 5 over 2, and then divided by the new power. So negative 5 over 2, and you let it having this infinity and also 16, and you let it equals to 1. Okay, so next, what should we do? Alright, so I don't like all the constant inside here. So usually before I try to simplify it or whatsoever, I will try to pull out all the constant. So when I pull out the negative 5 over 2 as the denominator and bring it out, I will have negative 2c over 5. And then the term inside, I will have 1 over x power 5 over 2 because the power is negative, so I can bring it down. Okay, and after that, what can I do again? Alright, so I want to continue and put in the value for infinity and 16 in the equation. Alright, so negative 2c plus 5, I just copy it first. Okay, when you put infinity into the x, right, 1 divided by infinity, of course, you'll get the value 0. Okay, or it is very close to 0, so usually we'll treat as 0. And then minus, substitute the 16 into the x, you'll get the value 1 over 1, 0, 2, 4. Okay, and then it is equals to 1. So if you try to multiply and simplify everything here, you'll get 1 over 2560 times c equals to 1. And therefore, you can get the value of c, which is 2560. Okay, so the whole process actually involves the integration. So all the integration here, you learn it before in AS level. And for recent years, they are going to test you about the A2 integration as well. So later when you go for the integration chapter in A2 level, right? So please make sure that you know how to integrate all the function correctly, right? Because you might need to use it in statistics also. Okay, but for the example here, we try to take all the simple ones so that we can discuss it first to make you understand. All right, so our C is 2560. So again, how to get the C? So we are using the first property that we learned just now, which is when you try to integrate the whole domain defined in the function, okay, and then you try to let the integration equals to 1. And then from there, you will continue to do the integration process and you can get the constant very easily. Okay, then now let's continue part number B. Okay, so for part number B, they want to find the probability that a person in this profession chosen at random earns between 20,000 to 30,000 per year. So you want to calculate the probability. Okay, so how can you get a probability here? Okay, so if you put probability, integrate from 20,000, because you're asking for 20,000 until 30,000, right? And then what's the function you have? So you use back the value of C just now, and then x power negative 7 over 2 dx. Okay, so if you want to find out the probability like this, by writing out 20,000 and then 30,000, this is wrong. The step is wrong. Why is it wrong? Okay, so for the integration, you shouldn't put 20,000 until 30,000. You should put only 20 until 30. It is not 20,000 to 30,000, but instead it is 20 until 30. Okay, so again, why? Please look at the question on top also. They tell you that measured in thousands of dollars. So that means 16 means 16,000 already. So if let's say they're asking for 20,000 to 30,000, right? So that means when you do the integration, it should be 20 to 30 only. All right. Then after that, this is something simple. For me, I will pull out the constant first. Then only I do the integration for x. So x negative 7 over 2 plus 1 becomes negative 5 over 2 divided by negative 5 over 2. And then you need to put in the value for 20, 30, and 20. All right. So I will leave this part for you. If you didn't do it wrongly, then you should get 0.365. So this is a probability that we get. Alright, so for this particular question, we applied both properties that we learned just now. The first one is when you try to integrate the whole thing and you let it equals to 1, so that's the first property. The total area under the graph equals to 1. And the second property here is to find the probability, you need to integrate the area under the graph also, but you're having some different limit. The limit here will be given in the question. Alright, so you just apply some simple integration, then you can get an answer for probability. Alright. Okay, so this is what we have for question number 1. So I hope that you understand about this. Okay, so let's continue to example 2. Okay, so again, if you read the question here, you will see that there's a continuous random variable again, and then they give you the function. Alright, okay, so first they want to draw a sketch of the probability density function. Okay, so they want you to draw the graph. Alright, so how can I draw the graph here? Again, you might need to apply the basic concept that you learned before in AS level. That means how you do a transformation or how you draw a basic curve. Okay, so if let's say you're having kx squared, the first value that you need to put in is a 1 because it is the smallest value. So when you're having a 1 here, the value that you get should be a k. 1 squared times k is a k. Okay, and after that, when you substitute the value 4, because the largest value covered from this graph is 4, so you substitute the value into the equation, and then you will get that it is equals to 16. Therefore, this particular value will be 16k. So it should be a curve. So you can draw a curve like this. Because it should be a U shape, right, for any quadratic equation. Alright, so my curve maybe is not curved enough, but you can write it better. Okay, so this is the sketch that I have. It should be a curve going up. Alright, so you can label it as this is y equals to kx squared. So this is how we sketch the graph. Alright, then for part number 2, they want you to find the value of k. Okay, so as what I told you before, to find the value of k, you need to apply the property, right? So when you integrate the whole function from 1 until 4 for kx squared, and you let it equals to 1. Okay, so for this part of integration, I'm not going to show you how to do it. So please complete this one yourself. Eventually, you should get the value k equals to 1 over 21. If I didn't do any careless mistake or I didn't write out the answer wrongly, you should get this one. All right. Okay, so the steps here, you just try to complete it yourself. Okay, then for third part, calculate the probability of x between 2.5 until 3.5. Okay, so again, to do the to find the probability, you need to do integration. So integrate from 2.5 until 3.5. And then what is your basic function here? 1 over 21. K is 1 over 21, right? And then x squared, then dx. So if you continue from here, and then you should be able to get the answer 0.433. Okay, so all this basic one, I will just leave it for you to complete it. Alright, but I just guide you roughly how to go through, how to set up the question. Yeah? Alright, then next one. Next example. Okay, so my file is loading. I have to wait for a while. Okay, then continue further. Alright, so example 3. Okay, so for example 3, they give you a curve, and then they sketch a curve for you. Alright, and then for this question, they ask you to calculate the probability that more than 5 kilo of the substance is produced in industrial process. Alright, so more than 5 kilo, which means x, okay, should be more than 5. So how you find the probability for x more than 5? So again, you integrate from 5. Is it until infinity? No. Alright, what is the largest value in the function defined? The largest value is up to 6. So when you want to find the probability for x greater than 5, integrate from 5 until 6. So this is not infinity here, it should be a 6 only. And after that, you need to integrate this one. 1 over 36 x and then 6 minus x dx. Alright, so again, 1 over 36 is a constant, therefore I will want to take it out first before I do any integration. And then for x and multiply with 6 minus x, right? What you need to do is you have to multiply the x into the bracket first, which becomes 6x minus x squared. Then after that, only you start your integration. Okay, because this is product, right? X multiplied with something. So in our rules for integration, you cannot straight away integrate like that. You have to expand it. Okay, then expand it into 2 terms. Then only you can integrate terms by terms. Alright, so if let's say you didn't do any careless mistake, then you should get 0.0741. So again, this question is very simple. It just need you to involve your integration only. Apply the integration rules. Right? Okay, so this is not Okay, let's continue to example 4. Okay, so if you look at example 4, they are talking about the error in grams. All right. It is given like this. Fx equals to k. K is a constant from -3 until 7. So first, they want you to find the value of k. Okay, so now, when they give you the figure, right? Okay, and then, how to say, right, so maybe when they want you to find the k, by right, we should use the formula that when you integrate from -3 until 7, okay, for the function k, it should be equals to 1. So this is a property that we learned just now, right? Okay, so you can use this one, of course, no problem. Okay, but sometimes if they give you a figure for the function, and then if you realize that the figure is not a curve, but it is actually a shape, like a square or maybe a rectangle. So for this case, it is a rectangle, right? If you can see the graph here, your graph defined is actually a rectangle. Or maybe sometimes they will give you a triangle. Or maybe sometimes the shape looks like a trapezium. Okay, so if let's say you are having all these kind of shapes, which is not curved one, then you can use some common sense to help you in doing the calculation. All right, so like for example 1, if you don't want to do the integration, right, there's another way for you to get the value of k. So what is it? You can use the common sense. Because when we talk about the integration for the whole function, right, it is the area under the graph. So if let's say you look at this rectangle, what is the area under the graph? So to find out the area of a rectangle, you need to take base times height. So what's the value for base here? So you have 3 plus 7, which is 10. So 10 times height. So what is the height is k. And it is equals to 1. Therefore, your k will have 1 over 10. Of course, when you want to do the integration, you still get the same answer, which is k equals to 1 over 10. But if you want to save time in the exam or you want to have a simple way, then this is what you can do. But only restricted to the certain shapes, right? Like square, rectangle, triangle, and then or maybe a trapezium. Alright, so this one you'll see that I didn't involve any integration, but I just use a common sense that the area of the rectangle and I let it equal to 1, then I can get the value of k very easily. Okay, alright, then now let's continue to part number 2. They want you to find the probability that an error is positive. Okay, so when they actually want you to find out the probability that an error is positive, so error positive means that they want you to find out the probability for x greater than 0, means positive. Then if you want to find the probability for x greater than 0, you can use the integration from 0 until 7, and then for the function k, so the k is 1 over 10. So if you continue for this integration, you will get the probability. And again, some students, they will want to use the common sense. Right? If you want to use the common sense, that means that where is the area that is more than 0 for the error, for the x. So this is the area. The error is positive, means the value of x is positive. So this is the area. So sometimes if you want, you can straight away use the common sense also. So what's the area here? So you take the base, which is 7, multiply with height, which is 1 over 10, and it is equals to 7 over 10. So the answer for the probability is 7 over 10. Very, very easy. So if you don't believe, you can try to do this integration and see whether you get the same answer or not. It will be the same. Okay? So I hope that you can roughly link out, right? If let's say I want to use common sense, okay, by looking at the area of the rectangle, how can I get the answer that they want? And also if you want to try, you can try the integration also. Alright, because we learn the integration, but sometimes if you want to save time, you can use the common sense. Alright, okay. Continue to the next example, third question. Okay, so for third question, they are saying that they give you important keyword here, given that. So I think I told you before, right? For when you see the word given that, it means what? It means that this is a conditional probability. Okay? All right. So if you write out the symbol, you will have something like slash. Okay. So given that error is positive, so error is positive. When you write here, it should be x greater than 0. Okay. And then after that, find the probability that the error is less than 4. So you want to find the probability that you are having x smaller than 4. Okay, so when you are having a conditional probability, the denominator is the probability for this one, the event that given first. All right, that already happened, which is given that one. Okay, then now you look at this one. They want to have x smaller than 4 intersect with ax greater than 0. Right or not? So when you want to simplify this one, in short, it actually means that x is more than 0 but smaller than 4. So when you rewrite it, you will have something like this. X is greater than 0 but smaller than 4. Okay, so when I write it out, it will become x smaller than greater than 0 and smaller than 4. Okay, then after this, what should I do? Alright, so for the probability of x greater than 0, you already calculate it just now, which is 7 over 10. Okay, so for the top part, if you want to apply integration, then you can apply integrate from 0 until 4 for 1 over 10 dx. If you don't want, then you can use common sense like what I showed you just now. So you roughly imagine that you're having a 4 here. So for 0 until 4, what is the probability? Okay, so this one I will show you the detail again. If you didn't do any careless mistake, then your answer should be 4 over 7. Okay, so this is how you solve it. And the last one, part number 4. Okay, so for part number 4, they said the error, the magnitude of error is less than 2. Magnitude means what? Means modulus. Alright, so the modulus of error means magnitude of error smaller than 2. Okay, alright, so you learned modulus function before, right? So when you're having modulus x smaller than 2, what will you have? You will have it as negative 2. X is between negative 2 until 2. Okay, so again, you can use the integration if you want to find the answer. If you don't want, then again, you can use the common sense to do it. So by using the area of the rectangle. Alright, again, I won't show you the detail of the steps here. So if you continue go and try it out, right, then generally what do you have is you should have the answer which is 2 over 5. Okay, so again, if you look at all the 4 examples here, right, generally I hope that you should have the idea already that how we actually use the property to find the constant and also find the probability for continuous random variable. Okay, and then for particularly this example 4, right, you realize that the graph itself is actually a shape, maybe like a rectangular, triangle, whatsoever. So you can use common sense about the area of these shapes to get the probability also if you want. If you don't like the integration, I can tell that we seldom have this kind of question. Okay, so if let's say you have, then maybe you can get full use of the figure, right? Okay, so maybe the last example for this video. Okay, so for the last example here, they give you a continuous random variable t. So this is a function here. Then this is a curve. This is a graph. So you can see that there's a curve actually. It is a curve actually. And then they want to find the value of k. So again, for first part, if you want to find the value of k, what you need to do is you need to integrate start from 1 until infinity for the function. Okay, so you can continue from here. I'm not going to show you the answer here. Oh, sorry. You have to let it equals to 1 first. Sorry for that. Okay, so you have to let it equals to 1 first. Then after that, you carry out the integration. then eventually I think you should be able to get the k equals to 3. Okay, so this is what we have. Alright, then after that, again, you carry out the probability part. Okay, so I just leave it for you. I hope that you already know what is the value that you should do, how should you get the answer. So this one should be 0.704. Alright, okay, so generally for this video, we only learn two basic properties, okay, for the continuous random variable. The first one is when you integrate the whole function from negative to positive infinity, you should let it equals to 1. That means you get the whole area under the graph and you let it equals to 1. The second one is when you want to find the probability for a certain number to another number, then again you do the integration for the limit with that values and you will get the probability for that particular question. Alright? Okay, so I hope that you understand all the idea that we have here in example 1 until 5. Okay, so for the next video, we are going to discuss how to use the function to get the median and also the quartiles. Right. So this is what we have for this video.